be watching the graduation, but we need to find time to progress with our lectures. So we have to continue from where we ended from last week. So under binomial probability distribution, we did, I think, 2 examples, and we looked at that example and we realized that the binomial probability distribution is usually used for events where the sample size is very, very small. Okay. Then one thing we didn't look at was the mean and the standard deviation for binomial probability. So when it comes to the mean is given by n multiplied by p. So in this case, the n, that is the sample size that is already given in your question. Okay, and the p is the probability of success, which is also given in the question. So all you need to do is to get the n as a sample size and the p, multiply the 2. So in the previous example, what was the n? What was the n in that community where we did the sampling? Was n equal to 6 or 5?
5.
It was 5. Huh? Someone said 4.
It was 5, sir.
5. Okay, good. So we say our n, we get that one, is equal to 5. And what was the probability p of success? What was the probability of finding someone with what type of cancer was that?
.4, sir.
0.4. Therefore, if the probability p of success is 0.4 and the sample size is 5, our mean becomes 5 multiplied by 0.4, which will give you something like 2. Okay, this one is straightforward. Unless someone has a challenge, so that is the mean. Then standard deviation is given by square root. This is square root of n multiplied by p multiplied by q, where n is the sample size, p is the probability of success, q is the probability of failure. So you have everything in your question. So if p is equal to 0.4, then q will be equal to 1 minus 0.4, which will give us 0.6. N is equal to 5. So just substitute where there is p, where there is n, put 5. Where there is p, put 0.4. Where there is q, put 0.6, and multiply these. That answer, find a square root. Okay. So we are saying standard deviation given by S is equal to the square root. Let me just get this square root. So square root of 5 multiplied by, so square root of 5 multiplied by 0.4 multiplied by 0.6. Then you find the square root. What answer do we have? Yeah, how many class you have?
It's 1.095.
1 point
0.095445115.
5. 5 multiplied by 0.4 by 0.6. Okay, so that's 1.2. You find the square root of this answer. All right, so our standard deviation is equal to approximately 1.2. Okay,
Yes, sir.
1.2. Correct one decimal place depending on the instructions. If it's 3 significant figures, then to become 1.10. If it's correct to 2 decimal places, to become still 1.10. Same concepts. Okay. So here all you need to know are the formulas. The rest just substitution because everything is there in your question. Then variance, we are saying variance is equal to S squared. Hello? Yes?
How is 1.2 coming there?
Yes, that was what I
Sorry,
was.
not 1.2. 1.1, right?
Yes, sir.
1.1, right? Yeah. Thanks.
Yeah.
Thanks for that observation. Yeah. You know, we're getting odd.
What did we understand?
Value equal to standard, but we did even under measures of central tendency and dispersion. So this is under measure of dispersion. Variance is equal to standard deviation squared. If you have the variance, you want the standard of deviation. Standard of deviation or standard deviation is equal to square root of variance. So here, the variance is equal to a squared. How do we find the variance then? So variance is equal to 1.1, or write everything 1.095 squared. So everything I'm writing here is already squared. Yes. Okay, squared. So write squared. What do we get? Peter, shine.
1.21.
We get 1.21. So this is squared. 1.2. Okay.
Yeah, see, this is 1.2.
Hello. So our variance is therefore, let's happen. Our variance will be equal to 1.2. Are we together? All of us, are we on the same page? Is that okay? Hello?
Yes, it's correct. 1.2.
1.2. Okay. So I wanted to finish this under binomial probability distribution. So it is done. Done, I will never do it. Okay, you need to understand the concepts, and you need to understand, or you need to know these are used or applied. Any questions before I proceed? Any questions before I proceed?
I think it's clear, sir.
Very clear, right?
Mm.
All right. Okay, so we go on today's focus now. That is another discrete probability distribution. That is Poisson distribution. Comrade Poisson, are you here?
Very much following, sir.
Arpeng is around.
It's very much available.
Poison.
Professor Poison. Professor
Arpeng.
Poisson. So
Very much following, sir.
very much following, right? So to look at Poisson probability distribution, I want us first to look at the characteristics of Poisson distribution. Okay, what are the characteristics of Poisson probability distribution? So the first thing we need to know is that this type of probability is used for events that occur at random. Okay, random events. For example, we do not know the number of patients that visit a particular hospital every day. So there are actual variations. Today, you may have 30 people visiting the hospital, okay, for their healthcare services. The other day you have 2, the other day you have 100, and so on. So these people, they go to this hospital randomly, okay. There are many other events that occur at random. I think we gave some examples. So the population must be very, very large for Poisson probability distribution. Okay, but the probability of an event must be very small. For example, how many patients will be admitted at a certain health facility each day? Some health facilities may actually have report maybe 1 admission or 2 admissions, 3 admissions, and so on. So it's actually a large population, but only few people may be admitted in this case. Not everyone that goes to the hospital is admitted. The majority, they go back home. A few are admitted. So there you see that the probability of that event occurring is very, very small. Okay? So again, this is not a continuous type of probability distribution. Like I said, it is discrete. So we don't use continuous variables. Lastly, the mean and the variance are equal. The mean and the variance are equal. So if you found the mean of 5, it means the variance is also 5. But we'll look at the calculation of the mean. Okay. So those are the 5 characteristics. Any questions? Professor Poisson. So the mean is equal to the variance and is equal to NP. Remember the N, the sample size, the P is the probability of success. This NP is equal to this symbol you are seeing here, lambda. Okay? This NP is equal to this symbol you are seeing here, that is the lambda. As we do the calculation, you will see where we apply the lambda. Then standard deviation is given by the square root of NP or square root of lambda. Okay, so the mean is equal to the lambda. The variance is equal to the lambda. Therefore, if you have the variance, we know that standard deviation is equal to square root of the lambda or square root of the variance. So it is easy to find the standard of deviation. So we'll do examples of how to calculate the mean and the standard deviation when we are done with the actual calculation of Poisson distribution. Okay. Now, I left this blank so that we do the formula together as I explain what each of the variables are going to say, of the variables are going what they mean. Okay. And hope you have the calculators because things you need to know them. You need to know how to use a calculator for you to calculate certain variables. Okay. So are we here? I know sometimes you switch on you turn on your Zoom,
Yes, sir.
but you leave your phone alone. Then you start cooking, start watching a movie. All we know is you're playing, but you're not. Where's repeat?
No. I'm very much following, sir.
Okay, great. So let's look at the formula for calculating probability when you are using Poisson distribution. So the probability of a variable x is given by okay, is given by, are we there?
Yes, sir. We are
I.e.
here.
Romans 8 verse 28, thank you, is given by E, Okay. E, if you look at your calculator, I don't know the one you have, Chinese or not, but there's an E. You can see E to the power X, but this is not basically an E. E to the power X, something like that. Then when you look up there in pink, there's another E. Now you can see like it looks like an E that is written in italic. So that's exponent. Okay. So later on I'll show you how it looks like this. Then it looks like this. I hope we're able to notice the difference. So the formula is E to the power negative lambda to the power negative lambda here. Okay. I drop this. Okay. Then multiplied by, so here I can leave a space and I say multiplied by, multiplied by, no, I can use this one. Okay, multiplied by, but even if you don't put a multiplication, just leave it like that. Multiplied by lambda again. Okay, now lambda to the power x. Okay, where x is a variable. Okay, x is a random variable. Okay, so now all these you have written here must be divided by x factorial. X factorial. On your calculator, you can see, for those who are using a calculator like mine, you can see there's on top there's shift, there's alpha, and then there's x factorial. X factorial. I hope you're able to see x and something like an exclamation mark. X variable and an exclamation mark here. So on my computer, I can show this. I go to shift and then this part here. That's factorial. X factorial. So we have a formula there. We have a formula E, which is exponent to the power negative lambda multiplied by, so the powers here are 2. We have negative lambda there on top, and then we have x here. The powers are 2. Take note. The exponent and this lambda are not powers. So exponent to the power negative lambda multiplied by lambda to the power x, everything here, everything divided by x factorial. Okay. So where x is a random variable, E is exponent, what is lambda? Lambda is the mean. Lambda is the mean. Okay. X is a random variable, and this is the factorial. Okay. We are here. Moisson probability. That is the formula you guys know. Okay. In the exam, I will provide this formula. In your test, I'm not going to provide it. So the E or exponent, this one, is equal to 2.7. In the question, I may use mean or I may use average. So I will let you know. Okay. So how do we find a factorial in the manually or on the calculator? Example, factorial example. Oh no, let me not start with factorial. Let me start with exponent. Are you able to see the calculator? Are you able to see?
Yes.
Okay. Now, on the calculator, if you check where there is E, you can place where there is E. When you do that, say, when you just place E, what will come is ln. What will come is ln, right? When you do equal to, it will give you something like this. Are we together? Now, change, try shift. Shift, then place E, and this say equal to. You are going to get 1.2. So then how do we find the exponent E as exponent of 10? This, you go to alpha. I'm able to see alpha on your calculator. Go to alpha. Please take note. You need to write for you to know the step. Write down, go to alpha, place on alpha, and then after that, place E. Okay? When you do that, so alpha, then E. So when you place alpha and you place E, the E even changes. It shows you that now it's an exponent. I hope you're able to see.
Yes, sir.
And once it does that, just do equal to. You have the value 2.72. The 2.72, I just rounded it off. The entire value is this 2.71828218282. But you know, when you're calculating and you've rounded off to 2.72, the answers you'll be getting will be closely related to N1 using the entire value. So I can still mark you correctly. So in case you're saying, by the time I'll be going to alpha and E, it will take time, you can still use the 2.72. Make sure you don't make a mistake. It is good to consult your calculator. So we are done with the E. Anyone having the challenge? There are some calculators that do not have certain there are certain calculators that do not have certain functions. Are we okay? Are we okay?
Yes, sir.
Okay. Devson is okay. Other people?
Yes, I am.
Yeah, Devson.
Sammy,
Yeah.
I'm not okay.
How are you feeling?
I'm fine. I mean, I'm not okay on the E.
Oh, okay, okay.
Yes.
What is the problem, Rand?
The problem is that when I press alpha and E, there's nothing coming on my calculator. There's nothing coming on my calculator.
Are you using Casio or?
It's Casio.
Okay. Try to go on E directory and press equal.
It's bringing lean and then equal to its 1.37.
Okay. Try shift.
Shift E and then equal to. It's an error.
Okay. Alpha again. So when you press alpha, press
okay.
alpha, then there should be a capital letter A that must appear. Have you seen
letter
it? A on the screen of your calculator when you press.
Yes, there is. Yes.
Then go to your E.
Okay, I've gone to my E.
And then say equal to.
Then say equal to. Still nothing.
Is that a Casio or Poisson calculator?
I think it needs a Poisson calculator.
The calculator is Casio FX991ES Plus.
Okay. When you remove everything, just put it on. I'm able to see a letter D. I'm able to see a letter D.
Yes.
D.
Yes.
Okay. But what's the E you are pressing on? How does it appear? Like, is it E to the power X?
No, it's E to the power. It's just E and there's nothing on top. It's blank. It's not to the power X.
Okay. Okay, start. Maybe come. Someone wants you to go for tutorials. Yeah, Chris is offering.
Okay, then I'll go to Chris.
Okay, you're welcome.
All right, thank you.
Yeah, so for the sake of those who are having challenges on how to find the 2.72, so what we do, let's use the 2.72 that I've given you, but with time, just try your calculator where there's E, alpha, and shift. Try these. At some point they'll give you the 2.72. Another question, do you have on your calculator a button written DIN, something like IN or LN, DIN? Then do you have DIN on your calculator?
Yes, I do.
Where is it?
It's written on the button, and then the E is just on top of the IN. Yes.
All right. I don't know why it's fading. See, just alpha, then the same DIN, and once you do that, the E comes. And the next thing you do is equal to. Just keep on practicing. I think you'll get it later on.
All right, I will.
Okay. Then the factorial. How do we find it without using a calculator? So any number, for example, if we say 0 factorial, actually factorial begins from 0. When you do 0 factorial on your calculator, you will get a 1. Okay. That is using your calculator. Then you move to a beta number. Let's say a bigger number, better than 0. Maybe let's say 5. Let's say 5 factorial. This means that's manually. This means starting from 5, you do 5 multiplied by the value that follows 5 is 4, multiplied by value that follows 4 is 3, multiplied by 2, multiplied by 1. So 5 factorial basically means 5 multiplied by 4 by 3 by 2 by 1. When you do, you'll find a certain answer. 3 factorial means 3 itself multiplied by 2, that's a value which follows 3, and then multiplied by 1. So when you're doing that, you make sure you end at 1. Because if you end at 0, your answer is going to be 0. Okay? So try to multiply 5 by 4 by 3 by 2 by 1. And then prove with your calculator. On your calculator, where you can see factorial, I'm sure, somewhere there. So what you do is go to the number 5 on your calculator, 5, then 5, then press shift. Okay? Press shift and then where there is factorial. Okay? So you have 5 factorial. And just say equal to. The answer is 120. Multiply this, it should give you 120. Are we okay?
Yes, sir.
Yes, sir.
Okay. All right. Good.
Sir,
Yes.
Malpeng.
I know.
you know what?
Yes, Peter.
Sir, you know,
Huh?
could you just kindly repeat that so that we are on the same page?
Okay. On your calculator, you can see where there is X exclamation mark. That's X factorial. We should log in. We should log in soon. The time will be over. Just log in back. But you can see X factorial.
Yes, sir.
Okay. There's Infinix telling you and place shade, then e to the power 1. Now I don't know the color of the shade or the size of the shade and so on.
6.
Factorial 6. Try 10 factorial. Everyone, please practice 10 factorial. That's 10 shift. Then you go to factorial equal to.
For me, it's giving me 3,628 point 3 million. 3.6 800.
It's 3,628,000. Eh?
You see, 3,628,800.
Yes, correct. Correct that way. Then 6 factorial.
6 factorial. It was 10 factorial.
6
now
factorial.
It's 720.
720. Okay, that's how we use the factorial. Okay, so we come up with values. When we tell you maybe 8 factorial, 10 factorial, and so on. So I've explained what is in the formula. X is a random variable, and that's a variable. Okay. Yes, Miss Ero.
So Mundo is kindly asking that you can add her to the group.
Who?
Mundo.
Muy. Okay, I've done so.
Yes. Okay.
She's joining. Yeah. All right. Okay, so that's how we use factorials. Okay, so if you want, just get your calculator, use a number, try 7 factorial, 7, then you go to shift, and then the factorial, and it will even appear there, 7 exclamation mark. But that's not exclamation mark, it's 7 factorial. What do we get? 7 factorial?
5,040.
5040.
50 votes, 5,000 and votes. If you got that, then you're cool. If you didn't, then you're behind. So we need to help you so that we work together. If you didn't, please ask and it shall be given. It shall be given unto you. Okay, so we are all cool. Then we can move on. So I've explained X is a random variable. And like we used last time, we used X where we say maybe no one with this condition or no probability, 1 probability, 2 chances of this, 3 chances of this, and so on. So we'll get to try that. Then E, we have practiced E or exponent. This symbol, that's lambda or an average or a mean. And the last one is the factorial. Okay. So you can have different 0 factorial, 1 factorial, 2 factorial, and so on. 2 factorial, and so on. Okay. Now, here is a question or an example. Please, you need to write down a hospital receives an average, 5 emergence cases per day. Calculate the probability of the hospital receiving semicolon, the hospital receiving A, or number 1, see, A, no case per day, so meaning it's approximately that per day, averagely, they receive 5 emergence cases. But now we're saying calculate the probability that they will receive no case per day, then 1 case per day, then at least 2 cases per day. You know what this means? If we have to interpretation, it means that for A, X as a variable will be equal to 0. For B, 1 case, X will be equal to 1. For C, X will be equal to or greater than 1 or greater than 2. That's what it means. Now, that is, these are the values of the X, which will be a random variable. So as you are calculating for A, where there is X in the formula, you put for A you put 0. For B you are going to put 1. For C you are going to put we'll not even put anything. We'll go back to what we did last time. Since we said the probability of 0 and 1 have been calculated, and they are the only ones that must miss from this other side. So we trace that 1 minus that probability, then we find the answer. Okay. interpretation. Okay, then we look at what is what we have from the data. What have we been given? And then we compare from the formula that we have. What is missing? What do we have? What is missing? What don't we have? Okay, we bring the formula here. Bring it here. Good. All right. So we say, no, not like this. Okay, like that. So we are saying from this formula, X is what we have listed down here. What about we move to E? Okay, E we do not have. It is there in the calculator. If we don't want to use the one in the calculator, then we're going to say E is equal to 2.72. Okay. Usually we discourage using these rounded off numbers because the answer tends to be slightly different with others who have used a complete value without rounding off. Okay. Right. So that's E. Then we go to the last one because X, we have X here, X there. Then we have E. Then what is remaining is the lambda. Okay. So we insert the symbol. Lambda is equal to mean or average. Do you see an average in the question? Anywhere where it's written average?
Yes.
sir.
5.
So per day they receive an average of 5 emergence cases. So that is your lambda. That is your mean, or that is your average. So your average therefore is equal to 5. If you have all this now, what can make you from finding the answer? Even if they say poisson, what can make you from calculating the answer? Nothing. So you get the formula. Okay, here's the formula. So we are going to A. Okay, we are finding the answers for A now. So we are saying A, no case. So X variable must be 0. X is equal to 0. Are we okay? So where there is X, we can remove even this one, put 0. Remove this X, put 0. Okay. Where there is E, what do we put? Where there is E, 2.72. Okay. But this is no value must be like that. And where there is lambda, so it means 2.72 to the power 5. That's -5, right? Yes, to the power -5. So there's a negative here. Please take note. Yes, there's a negative there. Then here again you put 5, right? So here we have 2.72 to the power -5. Okay. So here it means now you put multiplied by 5 to the power 0. Everything divide by 0 factorial. Right? 0 factorial. We move on. This probability will give us X is equal to 0. Now, you get your calculator. you get your calculator, or before maybe you do that, you can work out if you want 5 to the power 1, that is 5, 0 factorial, that is 1. So for me, I remove this part. It's not useful when you're using a 0 here or a 1. Because 1 factorial again will get a 1. 0 factorial get a 1. I usually remove this. I concentrate on this. Okay? So equal to, what is 2? What is 2.72 to the power negative 5? What do we get?
6.74.
6.74 times 10 to the power negative 3.
Yeah.
To the
6
power. Oh, okay.
Huh? What do you get?
6.74 times 10 to the power negative 3.
Yes.
Okay. That is if you have used the full value of A, isn't it? Without rounding off, right?
Yes, sir, the full value.
Yes. So let us agree on one thing. Since we all know how to find E from the calculator, let us use the full value without rounding off to avoid having different answers, right? So alpha E is equal to, so this value now to the power negative 5. 2.7, the whole value is there. So usually what you do, don't erase, just leave it there. You can just copy the answer. So this one is the same as 0 point, because I'm avoiding to write 6 point. Anyway, 6.737946 everything multiplied by 10 to the power who is listening to that song?
So I think for me, I'm a little bit behind.
Where?
I think it's my calculator, because mine is giving, when I punch 2.72 to the power negative 5, it's giving me 6.
It will give you 6.71.
Yes, 6.7.
Right? Yeah.
6.
Now
Yes.
we are saying this. Let's not use the 2.72. Let's use the entire value here, so that we have the same results. So you just write E. When you have that value, just do to the power negative 5. It will give you this.
Okay, all right, thank you. Yes, sir.
Okay, then everything multiplied by, what is 5 to the power 0? It's 1, right? It's 1, right? 5 to the power 0.
Yes, sir, it's 1.
Yes, so it means your answer is basically this here. P x is equal to 0 is equal to, I prefer you write correct to about 4 or 5 decimal places. So it will be 6.738 multiplied by 10. What's value? this value can also be written as 0.0067. Is it correct?
Yes, sir.
I can move from here 1, 2, 3 steps, right? And this is the 10 to the power negative 3. So it can also be written like this. Actually, some calculators will give you directly like this. They won't give you this 10 to the power something. Is
Yes, especially business calculator.
business calculators. So is this correct? Is this okay? Are we okay? And brother, sister behind? Okay. Are we okay? Yes, correct. So the only difference between part A and part B is that in part A, we multiply this entire value by 1 here. But here we are multiplying by 5. That would be the difference. So what do we have? Of power negative 5 multiplied by 5. Mine is giving 0.033689735. I don't know if I found the same values like mine. Are we on the same page? So P, X will be equal to 0, sorry, equal to 1. If we round off to 4 decimal places, we are going to have 0.0337. Is that okay? Yes. Correct. Good. Yes, correct. Okay. That is the value. Those who have found these answers, raise your hand. Okay. 2 people only. 2, 3 only. Okay. 4, 5. Okay, Christopher, Chola, Leandro. Great. 5. Richard, yeah, 7 people. Tasha, okay. All right, 10. At least 10 out of 60. All right. Okay, thanks. Now, when we go to part B, by the way, Chris, you should come to get your farmers practice papers. I won't be here tomorrow.
Okay, so okay,
Yeah.
so I'll come after this class.
Okay, my good sir, you'll find.
Okay, so thanks.
So part C, we are saying it's the same skill as the one we used under binomial. We are saying for part C, at least 2 cases per day. So 2 emergence cases per day. You know what that means? It's greater than 0, it's greater than 1. So we have to start from 2 going upwards. Okay? Maybe up to the maximum 5. Now, remember what I told you last time. If you are told 2 cases and above, you can calculate if you want each one of them. So you calculate for 2, the same process we did here. You calculate for 3, you calculate for 4, and you calculate for 5. Then you add these. You get the same answer as the shortcut and easier way that we are going to use. Okay, so as you study, even in groups, take time to try the old way of calculating. That's the old school. We are using the new school. Okay, so since we know the probability of x is equal to 0 and that of probability x is equal to 1. So we should subtract those from the entire probability, which is probability of 1. So probability that x is greater or equal to 2 is given by 1 minus, then we open the square brackets, probability x is equal to 0 plus, sorry, you even close here, plus probability x is equal to 1. I close the brackets. Okay, so what do we do? Same formula, right? I can write it in my case, I'll copy it and paste it here. Okay, the same formula, 1 minus, so we get the probability, the first one, 0, 0, 0 point. Guys, hold on just a minute. Doc, good morning. Fine, how are you? Doc, I did. Yeah, I did. You didn't pick. Maybe you are busy. Yeah. Yes, layers. Yeah. Yes, Doc. E. coli and salmonella. Yes. Yeah, definitely. Doc, to improve the practice and also know what is going on, we have to share the results. Yes. Tuesday is okay. Yeah. apparently, I don't know if they'll give us the Land Cruiser if it's available. If it's not, then we'll use our private transport. Yeah. It will be 3. Yeah. The VAs. Yeah. Okay. You need to have a motorbike when we come. Okay. Okay. You can do it between now and Monday. Okay, and it's a diesel engine. It's petrol. Okay, okay. So 10 liters. Okay. It means I will have to send some money on your line. Oh, okay. To him. Okay, no problem, Doc. Okay, thanks a lot. Yeah. Yes, per farm. Depends with the houses they have. If there are 2, meaning from each house we get 3 houses. Yes, 3 samples. Yes. Okay. All right. Thanks. Hello.
We are available, sir.
Okay. All right. Okay. So 0.0067. I'm sure you have even done this, not so? So here you don't say.
Yeah, coach.
Here you don't even include these X. What? You remove them. Just put brackets open. Then remove this bracket and put remove this and put, what did you find? 0.0337, meaning we are adding these 2 probabilities, we subtract from 1, isn't it? We are adding these 2. What's the addition of the 2? What's the value when you add these 2?
0.0404. 0.0404.
04. 0.0404.
It's a nice school. Mission Shan. And then she has found a place
Okay,
there,
so
like everything was set. No matter accommodation. No, there's no accommodation, no food, the house is there, no like she hasn't seen the situation.
Yeah, it's true. As well.
She wanted to go there, but because of accommodation, because of that same thing, she
This is serious. People are chatting and this is serious.
Who is SCM?
What's the final value? What's the final answer?
like he works with my brother time woman, so he's willing to pay for everything.
Hello?
I think that person needs to
and he
be
stays in Poland.
muted.
Then she wants to pay
Please mute on our behalf.
Yes, sir.
It's a good school.
Conversation here.
Around 5 things. Just mute her on your behalf.
Yes, sir. Better.
Balatumfishe thing to ala pofula. Okay, so is this our final answer? 0.9596.
Yes, after subtracting. Yeah.
That's our final answer, right?
Yes, sir.
SCM should apologize to me and to the class. What's her name?
Exactly.
Sorry, sir.
So this is our final answer, right?
Yes, sir, it is.
All right.
Yes,
so
sir.
that ends our meeting today. We continue with something else next week.
Sir, sorry, before hello, sir. Yeah, sorry. I have got a question just there. What about if in a question they have actually given us maybe the consecutive number like variables of x? For example, maybe on the one there was none, and then one case, two cases, and then at the end they're saying maybe at least four cases. They have jumped, maybe they have not on the question. I've not included maybe the three, but now at last they're saying maybe at least four cases. Now, when calculating, can
Where
we
did
include
where did you see that? Where did you see that? You see?
yeah, like what I'm trying to say. There's a question I saw.
Leave some secrets. They are called crocodiles. They are for the